afternoon and good morning, and welcome to today's webinar titled Keep It Running, Surface Drainage 201, Design Basics for Modular Trench Drain Systems, which is the second of our exciting two-part series on surface drainage. Today we'll cover the selection and sizing process for trench drains, and we'll also present a technical case study. This case study is interesting because it highlights how differing requirements on a single project site can influence the selection of trench drain systems. Presenting today are Dominic Turner from Armtech's Drainage Solutions Business Unit and guest speaker Jamie Kershaw from HAURATON. HAURATON is a global leader in surface drainage solutions. My name is Janine Yetke, and I'm the Director of Marketing for Armtech's Drainage Solutions Business Unit. My group runs Armtech's Drainage Solutions webinar program, and I'll be your host for today's event. We also have James Carter on the line, who is our technical moderator and who will be running questions and answers at the end of the session. Before we move into the presentation, I'll quickly go over some housekeeping items. At any time during the presentation, if you have questions, you can enter them into the question log. We will answer questions at the end of the presentation, and we look forward to some challenging ones. As a reminder, attending this session will qualify you for a 1-hour technical informal CPD credit. For those who have registered directly, we will send out the certificate to the email provided upon login. For those who are attending as a group, please compile your list of attendees and send the attendance list with the required details to webinars@armtech.com. I'll start off with a brief introduction to Armtech. We are one of Canada's largest infrastructure companies, supplying a full range of steel and HDPE-based bridge and culvert materials, as well as soil retention, stormwater management, custom engineered precast solutions, and standard precast products. Because of our convenient locations across the country, we are well positioned to serve your needs wherever you are. We serve numerous sectors from the municipal to forestry, transportation, commercial, retail, and residential construction. More about how we service these sectors can be viewed on our website or through discussions with one of our experienced sales representatives. With our centralized engineering department and regional engineers, Armtech has the exceptional capability to fully support design and challenging engineered project requirements. It's always exciting to announce new product offerings, and we're proud to announce that through our partnership with HAURATON, a global leader in surface drainage solutions since 1956, we have added modular trench drain solutions to our product lineup. With HAURATON's long history and extensive experience in surface drainage solutions in over 60 countries around the world, their products are known for innovative designs, and our sales representatives look forward to demonstrating how they can work for you. Presenting today are Dominic Turner of Armtech and guest speaker Jamie Kershaw of HAURATON, joining us from the UK. Dominic is Armtech's National Sales Engineer for HAURATON products. He is responsible for managing Armtech's portfolio of HAURATON surface drainage products. He has been with Armtech since 2013 and has experience with our full range of drainage solutions products. Jamie Kershaw is an international key account manager for HAURATON and has over 25 years of experience with the promotion and specification of surface drainage systems across a wide range of project types, including airports, ports, public spaces such as parks and town squares, and commercial and residential property. Both of them look forward to plenty of questions after this presentation. And with that, I'll now hand off this presentation to Dominic. Welcome, Dominic.
Thanks, Janine. So by now you should be able to see my screen. So welcome everyone to our webinar. Thanks for joining. Today's webinar will be is our second webinar on trench drains. And if you did not attend the first one, then don't worry, that's not a problem. So in this webinar, we will first review, do a quick review of linear drainage systems, so review of some key material that was covered in the first webinar. Then we will go into the main body of this webinar, which is the selection and sizing process. So this will include the those considerations, so the loading, durability, client requirements, and hydraulics. And then we will finish this by very interesting project case studies that Jamie will present to highlight the selection process you'll just learn in this webinar. So let's start with the review material. So some nice pictures of trench drain. Modular trench drain can be used in multiple applications from light duty to extra heavy duty. On this page right now, you can see light to medium duty applications like train stations, parks, walkways, building entrance, driveways. Then on the extra heavy duty and extra heavy duty, there are roads, industrial areas, service yards, ports, and also airports. Now let's see the different components of a trench drain system. So on this exploded view, you have all the components shown for a modular trench drain system. So the first component is the channel, which is the body of the trench drain that is usually 1 meter long, but can be also half a meter long. Then on top of it, you have a crate that is secured with a locking mechanism. In that case, that's a locking bar with one bolt. Crates are usually half a meter long. Then we have several end cap outlets and end cap that can be used to finish and start the drain. Then catch basin are also, modular catch basin are also available, 0.5 meter long, and they have a sump to retain sediments. There are also multiple outlet options regarding size and location. So it can be a vertical outlet, an horizontal outlet, or also different outlets option on the catch basin. Now, about the point drainage, so there are some issues that we can experience with point drainage. So first of all, the system is costly and complex. The installation is time-consuming because there's a lot of structure. Grading is more complex. Also, it's a non-even surface that is unpractical. What I mean by that is let's say a forklift, for example, in a service yard where you would have a point drainage system, then if it's highly load, then driving over an uneven surface can be a security issue. Now, on this picture on the right here, you see a point drainage system with a ponding issue, which is something that can happen with location where the surface is level or nearly level, like in that case. So if you would replace that system, that point drainage system, by a linear drainage system, then of course you would not have that ponding issue. Also, it's subject to blocking, like you can see on this picture. So leaves can accumulate, and since you have just a single interception point, then you can have those problems, which does not occurs with a linear drainage system. Also, it can be difficult to access, so it may increase the maintenance cost because of the poor access. Also, deeper pipe inverts, possible conflict with underground services as well. Now, in summary, the benefits of linear drainage is first of all, more efficient at intercepting runoff water. This is due to the large interception area, the grate area. Ponding is reduced or eliminated, even with the aging pavement, after which the water is still likely to find its way to the drain. Shallow depth of construction, so excavation is not deep with linear drainage. Easier grading, no reverse diamond shapes to be done, only 1 or 2 slopes in the drainage system. Also more economical because there are fewer components. Easy access along the entire length of the trench drain, and eliminates the roller coaster effect for vehicular traffic that you may experience with point drainage due to the undulating surface. Then last but not least, it's a very aesthetic solution. It can be easily integrated to landscape in a very elegant manner. Since we had several questions in the first webinar, again, about concerning the performance of trench drain in cold season, then we prepared a couple of slides to demonstrate the performance of those trench drain systems. So here we talk about the Recifix, which is the system we promote, the one made that is made of the body is made of composite, but it can also apply to other material trench drain. So first of all, it has a proven performance because Recifix system have been used over 20 years in also in location where the temperature can be low as -30 and lower, like in Russia or Scandinavia, where they have snow and a similar weather than we have. Temperature and frost resistant, so it's made of composite, so there's no problem. It can be easily -30. And if it's lower than that, then we would recommend to have a flow concrete encasement, so the concrete would go up to the surface, and it can fit purpose as low as -50 degrees in that case. It's unaffected by frost because there is no water absorption with the plastic and also the concrete encasement. And then corrosion resistant, composite as high chemical resistance, so unaffected by de-icing solution and salt. It's designed for extreme conditions, so the components are very durable, composite, and also galvanized steel, stainless steel, depending on the system. Structural integrity, so the channel ribs ensure anchoring to concrete that prevents channel from being pulled away from the concrete with freeze-and cycles. Also, snowplow, it can be installed, the system are compatible with heavy snowplow equipment we have, so it must be installed, of course, 3 to 5 millimeter below the adjacent surface, and then you have no problem with the snowplow's equipment. The system can withstand a load class rated up to F900 kilonewton. We'll get back to that, but that's the higher class. Impact resistant as well. And maintenance friendly, so it's easy to access. The narrow slots limit problem because the systems have a very high capacity. So it will perform well with some sediments as well. So this is an example of a project that have been Red Square, which is located in Moscow in Russia. So as you can see, as you know, they have a very harsh winter, and those systems are used, and it's a Recifix system, exactly the system we promote. So again, there's no issue with the cold climates and trench drain solutions. Okay, so now let's talk about the selection process. So there are several applications, location, requirements, all different depending on the application. So we need to choose the right product for the environment, so what we call the environment. At Armtech, we categorize this in five different zones to make it easier for you. So those zone 1 through 5, 1 is for light duty, 5 is for extra heavy duty application. So the first zone is residential areas, parks and garden. Second one is commercial areas, city centers, train stations. The third zone is streets and roads. The fourth zone is industrial areas, and the fifth one is docks, ports, and airports. So very heavy duty application. Now we'll get back to those zones later on in this presentation. So the selection process of a trench drain is very systematic. So there are two important aspects to consider. The first one is the project application. And then the project application has three considerations. So the first one is the loading. So what type of traffic and the traffic pattern is applied to the trench drain? Is it pedestrian, vehicular? Then the second one is the durability. So we need to look at the environment and make sure that the system is compatible to have a durable system. Then the third one is the client requirements that may include design preferences or legal obligations. So those are the important factors. We will go through them in details in the next few slides. The second aspect is the hydraulic performance. So we need to choose a system with a sufficient hydraulic capacity to make sure that the system is proper for the application regarding the design data. Those are the important factors, and those will be covered in the hydraulic sections in details. So let's start with the first aspect, which is the project application. So the first thing we need to look at is the load class. The load classes are very similar to to live loads, but it's specific to trench drain. So the number in the load class, let's take this example here, A15, and the 15 represent the proof load, so 15 kilonewton. That's the proof load that is used to test the system. So A15 is for residential areas used by pedestrian and cyclists, sorry. B125 is the common application would be sidewalks, pedestrian areas, and residential parkings. C250 is parking lots and general commercial areas. Now on the heavy duty and extra heavy duty side, we have D400, which is roads and street and other areas. E600, industrial areas used by hard tire forklift and heavy vehicle like ports, docks. F900, special areas with heavy wheel loads. So that mainly we can think of airports here. So the load class considers only a static load. So it's a specific footprint through a test block that doesn't take into account the dynamic loads. So that's why we need to look at other factors as well. So those other factors are first, wheel type and configuration. So depending on the footprint, is the tire pneumatic or hard? Let's take, for example, a forklift, then the impact and the stress will be greater on the trench drain. Also, multiple wheels spreads the load on the multiple axles and wheel, which reduce the pressure. The traffic pattern that includes the speed of the traffic, the frequency, is there any turning and braking forces over the trench drain? What is the direction of the traffic against the trench drain? Is it perpendicular at a certain angle or parallel? Also, is it prone to impact the location of the trench drain? Let's take, for example, at the bottom of a slope or bottom of a ramp, then you have a dynamic impact on the trench drain. Then we have also the location of the trench drain, but this will definitely influence the traffic pattern. So let's take the example of a trench drain that is next to a curb. Then you limit the traffic on the trench drain because it's near a structure. So this will influence the traffic pattern. So those other factors will influence the final selection of the appropriate load class. So you have to keep that in mind. Now, remember the zones I was talking about. So we have prepared some typical example just to show you how we associate how we choose the load class to the different applications. So this table here presents some typical application with a common range of load classes. So zone 1, which is domestic application, let's take the example of a domestic garden. Then the load class will be A15, can be also B125. So it's basically just pedestrian. So really, we don't need a very heavy-duty system. It can be light-duty. A driveway, on the other side, is also a domestic application, but the load class minimum would be B125, which is suitable for cars, small cars, without any issue. It could be also C250. Let's say you have a large truck and a trailer that is often used in your driveway, then you need to probably upgrade that to C250. Then the zone 2, commercial areas, city centers, train station. Let's take the example of a sidewalk. So the minimum is B125 because you have heavy pedestrian use and you can have also a car once in a while going over it. It can be also C250 depending on, again, the traffic pattern. If there is a heavy pedestrian use or if there is any maintenance vehicle, then it's going to be definitely C250. Shopping centers is similar to sidewalks, but usually pedestrian use is higher, and also you might have some delivery trucks and also maintenance trucks. So in that case, it can go also to D400 in that case. Another good example is parking lots. So parking lots is minimum C250, but can be also D400. It depends on the traffic pattern again. Can be also higher than that in some areas like a supermarket where you have a lot of traffic. The parking lot entrance on the others is another story because you might have a lot of turning wheels over the trench drain and also braking forces. So you must increase, it's going to be at least D400 and might be easily E600 low class application. Then zone 3, streets and roads. So let's take a residential streets where you put the trench drain next to a curb. Then D400 seems to be fine for a load class according to that situation. Now, if you have, like on the picture, a bus and that is going frequently over it, then E600 is the load class to consider. A truck stops is totally different than the roads because the traffic is not car anymore. It's going to be larger vehicle trucks, and so E600 would be the minimum. And depending where it's located, let's say it's located at the entrance, then you might have some braking and turning wheels again, so F900 will be more appropriate in that case. Zone 4, industrial area. So the first example is loading bays, so that's minimum D400. And then D400 would be if the trench drain is next to the building, for example. So you limit the static load on top of it and dynamic load. If the trench drain is not next to the building, then we would recommend to go with E600 because you'll have probably accelerating over it and also a heavy static load during the unloading. A service yard is a little bit different because you will have some turning, braking, accelerating. So E600 is the minimum, and it can be also F900 depending on the traffic pattern again, so the frequency and the speeds. Zone 5, which is the extra heavy-duty application. So Ducts and Ports is the first example. E600 is minimum. Usually we have in Ducts and Ports the container forklift, so this needs to be at least E600, and depending on the frequency and the load and everything, it's going to be it could be F900 also. It could be a good choice in that case, depending again on the traffic pattern. The airports, typically it's F900, but it can be also E600. Let's say it's a place where the plane won't go, then it can be a 600. So again, we need to look at what is the traffic and the traffic pattern, I mean. Now the other aspect, the other consideration after the loading is the durability. So the channel material is one aspect. So here we have objectively compiled different features of the common material used for trench drain. So we have composite concrete and polymer concrete. Now all those are fit for purpose in the trench drain application. Although there are some different features for every one of them. So let's see the difference. So the material, composite trench drain, they are made either of polypropylene, polyethylene, or HDPE. Concrete is, of course, made of concrete, but also can include fibers and steel reinforcement. Polymer concrete is mainly polyester resin, and also will have sand or aggregates. Now, if we compare the water absorption, which is an indicator of the frost resistance, the composite has no water absorption, so very good frost resistance. The concrete has a higher water absorption, so lower frost resistance. It is suitable for cold climate as well. It's just that it can absorb a little bit of water. The polymer concrete has a low water absorption. So chemical resistance, well, composites are highly resistant to numerous of chemicals, so it has an excellent chemical resistance. Concrete has a good resistance, may need to have some special additives depending on the chemicals, and polymer concrete has a high resistance. Now cutting and drillings, so for the composite trench drain, it's very easy. It can be done on site. For concrete, it's difficult because it usually needs to be done at the shop. And polymer concrete is even more difficult because it's prone to breakage. So we need to be very careful when we cut and drill polymer concrete product. Now on the impact resistant, well, composite has a very high impact resistance. Concrete has a medium to high impact resistance. Polymer concrete, that's probably the the disadvantage of the polymer concrete is it is brittle, so you need to be very careful during the installation process mainly. Then the environmental aspect, it's not really related to durability, but definitely to the material. So composite is made of recycled material and is 100% recyclable as well. Concrete trench drain are made of virgin material and they can be partially recyclable also. Mainly, the concrete will be crushed and used as aggregates. Polymer concrete has very low recyclable use. Durability also related to the grade material, so it will has an impact depending on the environment. So let's say you have a lot of de-icing salts that are used or a corrosive environment, then you want to choose a material according to that. Locking mechanism also will have an impact on the long-term durability. So a locking bar like that with one boat will be for a light to medium duty application. If you look at a high duty application, then you need this system with 4 boats will be definitely better for in terms of the durability of the system. Now the client requirements, so this is another aspect that can influence the choice of the trench drain. So the first reason can be aesthetic. So for some project, we want some discrete trench drain like this picture here, where you have a slot grade system, or it can be also a custom grade design to match the landscaping. Regulation, so it can be a local regulation for cyclists or disabled user like the ADA, Americans with Disability Act, where the width of the slot are limited to. Then safety, if we think of high heels, then we need to have small openings so we don't get stuck into it. Security, anti-vandal, anti-vibration locking mechanism, and also in that example here where you have an airplane, then you definitely want a system that has a grade that is not removable. Make sure you don't have any issue, security issue. Then the ease of maintenance can also be important. So a site that requires more frequent maintenance, then the system must be easily accessible. Now the second aspect of choosing a trench drain system is the hydraulics. So we need to, the idea is to determine the right cross section to meet the hydraulic performance. So this table here gives an overview of all the parameters influencing the hydraulic sizing trench drain. So A, catchment area length, that's basically the trench drain running length. Then the catchment area depth, B. So it gives you, those 2 parameters gives you the surface of the catchment, the catchment area basically. C, the rainfall intensity, the design rainfall intensity. Then D, the longitudinal surface gradient, so the surface along the trench drain. Runoff coefficient that is related to the permeability of the surface that will influence the runoff rate. Then the roughness of the channel material, which will influence basically, well, it's the Manning's coefficient. And then the outlet location, size, and type will also influence the discharge rate of the trench drain system. Also, the catchment area ground slope, so the slope perpendicular to the trench drain, can affect the intake efficiency of the system. So we have a powerful in-house hydraulic software that has been developed by HAURATON together with University of Prague. Armtech can provide hydraulic design to optimize and size the correct trench drain system. So basically we need some data from the project engineers regarding the drainage area parameters, the trench drain configuration, the outlet type and size location. We have an inquiry form that can be filled up to facilitate the process. Then the return output will be the trench drain outflow, the outlet flow velocity, and the most important, the hydraulic grade line in the channel to make sure that it doesn't overflow for a specific design data. The catchment area is the total surface that the trench drain uses to drain. There are two configurations, central or offset. It can be uniform as shown on the screen, but our software can also accommodate for non-uniform areas. Program use several methods that are all very simple and widely known, but it's necessary for adequate sizing of a trench drain. So the first formula that is used is the rational method. So it is used to determine the peak runoff rate or the design discharge of the system according to the catchment area parameters and the design rainfall intensity. Second formula is the Manning formula. So it's an empirical formula best known around the world, widely used for open channel flow calculation, and it assumes a steady and uniform flow through the channel, as you can see on this picture here. Now, when we apply that to trench drain, well, trench drain, we have a non-uniform flow and a non-steady flow. Because non-uniform, because the water depth will vary between successive cross-section along the trench drain, and also the flow velocity will also vary. It's a non-steady flow because we have lateral intakes, a constant addition of water along the trench drain. So that's why we need to we need a correction because of those two facts. So we call that the modified Manning's formula. And basically what we do is we increase the Manning's coefficient from 0.10 for the polypropylene to 0.025. And those results have been verified and confirmed by hundreds of laboratory tests. Another equation that is used is the energy equation. This is also used for open channel flow calculation. And since we have limited time in this webinar, I won't go into details of this formula, but all those formulas I showed you are used to calculate the depth of the water along the trench drain system, which is basically to calculate the hydraulic grade line. Another aspect with the hydraulic is the grade hydraulics. Very important, the capacity of a linear drainage system is limited by the trench drain dimensions and design, not by the intake capacity of the grades. So with just a few meters of trench drain, the channel capacity will be less than the grade intake capacity. So keep that in mind. So the combined intake capacity of grades installed over a trench drain run is significant if you compare to gullies, for example. Cut-off drain intercept sheet flow, so of water across a pavement surface, like on this picture here. So the grade design will influence the intake efficiency of trench drain in that case. So surface water bypass can occur, and this is if the grade intake area is reduced, if water volume is too great, if surface water approach at speed, if catchment area slope is steep, if grade intake has been clogged. So we require to make sure that this doesn't happen, to have a correct grade selection for the application and also a regular maintenance. So usually a regular maintenance, we recommend to do this once a year. Great. Now this is summary of all the grade options. So the first one is the perforated grade. So the intake is less. In that case, the interception is also less and may have a little bit more bypass. But the benefit is the aesthetic and also the small opening for a heel-safe design. The slotted grade, the second one, is, well, the intake will be medium to high, and this will depend on the width of the slots. The interception will be medium, and the bypass will also be medium. The benefits is functional, and also depending on the width of the slot, it can be a heel-safe design. Now, the mesh grade, will have the highest intake capacity and very high interception as well. So that it's functional and have a high intake. That's the benefits of this grade selection. Longitudinal has also a high intake and high interception, so low bypass. And this can be functional for ADA, so, and then also a high interception, so on the hydraulic, very good. Then we can also supply custom design grade, but of course the intake and the interception will depend on the design. But the main benefit is the aesthetic in that case. Slot grade, the intake will be medium to high, and this will depends on the opening of the slot. The interception will be medium and high, and the main benefit is it's aesthetic and discrete. So I'm done with my part, so I will now hand off this presentation to Jamie, and he will present a practical example applying the selection method we've just seen. So welcome, Jamie.
Thanks, Dominic, for covering the technical aspects of selecting and sizing trench drainage. Hi everyone, my name is Jamie Kershaw. I'm HAURATON's representative today. I have the easy part covering the case study. We chose this case study as it highlights the factors to consider when selecting trench drains. In this case study there were 3 different areas on the same project with different requirements. This is the case study that we chose. It was an industrial logistics development, a new build. The build was actually finished this year. The client was a specialist in development of logistics properties, and this is the area and the facility in question. The areas that where trench drainage was installed was a car park area, and that had an asphalt and block paved surface, an entranceway which was asphalt, and then there was a logistics area which was concrete pavement. In terms of project factors, probably the significant factor was prolonged rainfall, which we get a lot of in the UK. We're now having an increased incidence of thunderstorms. The highest rate of rainfall was recorded in Cumbria in 2015. Over a 24-hour period, we've got 340 millimetres of rainfall in that period. The rainfall intensity rates used to design projects varies from 50 millimetres to 75 millimetres per hour. But what's happening more typically is there's a climate change factor added to the rainfall rate to take account of higher rainfalls, higher incidence of rainfall. The project factors with regard to the car park was a large catchment area. They obviously required efficient surface drainage, asphalt and block paved surface. The area was trafficked by cars, light commercial vehicles, and the occasional surface vehicle. The traffic pattern was slow moving, typically in these areas, turning, braking and static loads. Obviously pedestrians were apparent in the area as well, so the grates needed narrow slots for ladies' high heels. There was a higher aesthetic requirement in the area because it was beside the office development, so they needed a system where the aesthetic appearance was maintained, and obviously the system was required to be durable, maintenance friendly, with low long-term maintenance costs. And we were looking for a system at C250 kilonewtons for this area. So the system that was selected was Resifix Pro. It was a 100 millimetre wide clear opening, which is the width across the inside of the channel there. The body was composite, PP, polypropylene composite. Units were 1 metre in length, and the weight of this unit was 4.99 kilos, which is obviously very, very light. The loading was C250 in accordance with the EN1433, and the grates were composite polyamide with narrow slots at 9 millimetres wide. And we had a central locking bolt and bar for each half metre grate section. Here you see the exploded view of the system, and then you see a typical installation with a block paved surface. The reason why we chose Resifix Pro was the system is totally corrosion resistant, the body and the grate, so there's no risk of oxidization on the grate, so the aesthetic appearance was maintained. There was a narrow slot opening of 9 millimeters wide and sufficient load capability of up to 250 kilonewtons. And these are common benefits that are relevant to all the systems that I'm going to mention today. They relate to all the rest fix systems. All have proven performance, all are very lightweight and quick and easy to install. All are safe and reliable for pedestrians and vehicles. All are hydraulically efficient, have high intake capacity through the grate, strong and durable, corrosion resistant, UV stable, and very, very simple to maintain with lower long-term maintenance costs. So those benefits apply to all the rest fix systems. The second area was the entranceway area, point 2 here. And this was a small catchment area. Obviously efficient surface drainage was required. There was an asphalt surface. The traffic was cars, light commercial vehicles and service vehicles again, but the traffic pattern was slightly different, with higher speed, accelerating off, maybe with a wheel sat on the grate, turning on the grate, braking on the grate, and static loads. It was more of a functional area, so the important thing was high intake capacity and durability. So maybe a slotted grate, heavier duty, and obviously durability and corrosion resistance was required. So we actually opted for an E600 system for this area due to the dynamic loads and stresses that were acting on the system. So we selected the ResFix NC trench drain. Again, that had 100 millimeter wide, clear opening, polypropylene. The body was polypropylene. The grates were ductile iron. The grade is actually equivalent to ASTM 7050-05. The slot with is 10 millimeters, so again, good intake capacity. And this system has 4 bolts per half meter, and the bolts are actually fixed into the edge frame of the unit. Here you see the expanded view and a typical installation in a concrete paved area. This system can actually take asphalt up to the edge of the trench drain unit, but here you see typically a concrete pavement. Another way of installing in asphalt is to install the asphalt up to the of the concrete surround. And why did we choose the NC for this application? High load capability of E600 kilonewtons, resistant to dynamic and impact forces. Obviously the secure grate fixing of 8 bolts per 1 meter unit, and the units were still quick and easy to install. The third area is the logistics area. So here you had traffic by heavy vehicles that were turning and moving over the system at speed. The project factors for this area was an extensive catchment area. Efficient surface drainage was obviously required. Concrete pavement was the surface, as you see here. The traffic was heavy goods vehicles, similar to this vehicle you see here with multi-wheels. And here you see the benefit of a slot channel type system in this location, with the wheel sat on the concrete surround rather than the trench drain system. So the concrete surround takes the load rather than the trench drain system. The traffic pattern was ultra heavy duty, accelerating, turning and braking, and also obviously dynamic and impact forces as well. This area was very functional, so we needed high intake capacity and with the efficient surface water interception. Durable and corrosion resistant system, maintenance friendly again, and in this area we needed F900 load capability. So this is why we chose the ResFix high cap system. 3 different trench drain sizes, 100, 150 and 200. The measurement is across the inside of the trench drain. And even with this heavy duty system, you see how light these units were. 1 meter long bodies. The bodies are again in polypropylene composite. You can see the durability with the structural ribbing on the system here. F900 loading. The grate has a slot width of 14 millimetres wide, and that's in ductile iron, in spheroidal ductile iron. Again, grade is equivalent to ASTM 7050 or 5, and we supply these grates with a KTL cathodic dip coating, so that's for extra durability and resistance. The intake capacity, some people feel that with these longitudinal slot type systems, these slot drain systems, that the intake capacity might be less, but in fact the intake capacity is very high with these systems. This trench drain that we chose for this particular area had a 40 millimetre wide slot. The maximum intake was about 6.5 litres per second per metre, and that's with a 20 millimetre water depth over the system, and that's equivalent to about 468 millimetres per hour over a 5,000 square metre area. So that will cope with any rainfall that you're going to get in Canada or anywhere else in the world. Here you see an exploded view of the system. It's step fall or different trench drain units, different sizes that you can interconnect. And here you see a typical installation with a concrete pavement with a longitudinal expansion joint, and you see the largest 680 unit here. And so the three different sizes were 100, 150 and 200. The 200 unit is 665 overall depth. And the reason why we chose this was obviously high load capability of F900 kilonewtons, resistant to dynamic and impact forces, high intake capacity, high system capacity as well, so you can drain extensive areas with 1 or 2 channel runs. Hydraulically efficient. With this system we have the option of providing stepfall configuration and also high level corrosion resistance as well. With this project we provided a comprehensive design using our hydraulic design software. So the consultant provided CAD drawings, site layout plan, drainage layout, and there were 2 rainfall intensity rates that we used on the design. In the car park areas and the entranceway area we used 30-year storm event, which was 30-minute duration, and that was equivalent to about 50 millimetres per hour in the UK. And the logistics area we used 100-year storm event, again 30-minute duration, and that was equivalent to about 63 millimetres per hour. They wanted to take the water off the surface a bit quicker in the functional areas, and the runoff coefficient was 0.8 for asphalt and 0.9 for concrete, and that relates to the speed at which the water crosses the surface and enters the trench drain unit. So here you see the hydraulic data sheet for one of the trench drain runs in the car park area, and you see here the area was 570 metres squared, the catchment area, and the maximum discharge was 6.22 litres per second. And we provided hydraulic data sheets for all the different areas, car park and entranceway, and also the logistics area as well. Here you can see on one of the trench drain light gradient, so the data sheet obviously represents that, and both systems had in the logistics area had a step fall configuration. Here you see the layout of trench drainage in the car park and car park entrance. So here you see the short run of Resifix NC for the entranceway with a catch basin. Then you have a longer run of Resifix Pro with 3 separate catch basin outlets, and then a shorter run as well of Resifix Pro. And you see these are all constant depth units. And then we have the Resifix high cap system used in the logistics area. There were 2 trench drain runs shown in red. This one here, there was a slight gradient on the surface, so we were able to get away with using smaller channel sizes, but this was a step fall configuration with 100 and 150 wide trench drain units. And then this run here was 150 and 200 because it was draining a larger area, you can see. And that trench drain unit was connected with an end catch basin, and that was connected to the end of this trench drain unit, and then obviously to your underground pipe work. Here you see a catch basin for the Resifix Pro, Resifix NC. The Resifix NC is the same box, same modular box, but a heavy duty grate. And here you see the larger catch basin for the Resifix high cap slot channel system. Again, you see the different knockout sizes for the different pipe sizes, so you've got some flexibility there. And here you see the some installation photos and project photos. This was a mid-installation showing the Resifix Pro system being installed, and here is the same location, the completed installation with asphalt one side and block paving the other side. And often the trench drain system is used to separate different surface finishes, so it's used as part of the aesthetics of the site. And this was the trench drain system that was installed near the bike sheds. And here, obviously, this system with the narrow slot, that's good for cyclists, because you don't get any problems with cyclists with the wheels getting trapped into the slot. And here you see the high cap system mid-installation. There's the unit being obviously that was installed, and the finished installation, very, very neat and very durable. Here you see the modular catch basin, mid-installation and then finished installation. What they've done here is they've protected the ductile iron from when they were pouring concrete, and again similar mid-installation and finished installation in the same position. And here you see an access point with these slot drain systems. Obviously, you need to get access into the system, so that you do that by going in through the access unit and also the catch basin. The customer was very happy, very satisfied with the high quality finish. The contractor appreciated the speed and ease of the installation due to the lightweight systems, very quick and easy to install. And my colleague Colin Taff, who was the regional manager, said throughout the process the contractor loved the product mainly due to the speed of installation. The end results look great, so the client was very happy as well. So that's a big thumbs up to Resifix Systems on this particular project. And that finishes my my case study for today. Thank you for your attention.
Well, thank you, Jamie, and thank you, Dominic. Thank you for your presentations, and thank you, everyone, for joining today's webinar. We hope that you enjoyed the presentation. Before we jump into our Q&A session, I'll quickly review a few housekeeping items. Please stay tuned for a Q&A session in just a minute. You can submit questions in the meantime. As you saw in the presentation, there are a lot of technical considerations for surface drainage design, and when the need arises, Armtech can help support you through the selection and design process. Please feel free to call at any time. Dominic's contact information is shown on the screen. He can help answer your questions or connect you with a local representative near your project location. Today's presentation was the second of our 2016 webinar series and the conclusion to a two-part series focusing on surface drainage solutions. We hope you enjoyed it, and in case you missed the first one, you can look it up on YouTube by searching for Armtech. Our next webinar in our spring series will be on April 22nd and will focus on geosynthetics and MSE walls. We look forward to you joining us then. To stay informed, please stay connected with us. You can follow us on social media, on Facebook, LinkedIn, and if you know someone who was unable to make it to today's webinar, they can view it on YouTube as well as all of our past webinars. You can also get the latest on Armtech by following us on our website, armtech.com. We value your feedback, and at the end of the webinar, there will be a quick exit survey, and we'd like to know what you think of this event. Question 6 will ask you if you're interested in receiving more invitations for Armtech webinar events. Please select yes. Due to strict Canadian anti-spam legislation, we are required to have your consent to receive future invitations for webinar events. So if you want to ensure that you're on our invitation mailing list, please choose yes to consent to our exit survey. If you do choose no, you will be permanently removed from all emails and webinar announcements. So please stay with us, choose yes. Again, thanks for joining today. To ask questions, please enter your question into the question log on the GoToWebinar interface. Feel free to ask anything you'd like, and if we can't get to all the questions in the time period, we will reply by email. And now we will move into our question and answer session, which will be moderated by James.
Thanks, Janine. A lot of good questions. Please keep them coming. First one, is composite material fully traffic rated? Are all grades traffic rated?
Okay. Well, it depends of the type of traffic we're talking about, but the Resifix Pro system has a grate made of composite polyamide, and this can be suitable for application up to C250, which means small cars, or it can be also small trucks. So again, it will depend on the traffic pattern, but for heavy-duty application, when I say heavy-duty application, I'm thinking of roads, streets, and application like that. Then a better choice of a grading would be ductile iron grade.
Thanks. For mixed-use applications, would one use either D400 or E600 be preferable? And I guess the issue is just clarifying. There was some confusion there. Is there one that kind of that is inclusive of the other? I think might be the best way to look at this.
Okay, I'm not sure I get the question, but yeah, D400 and is of course 400 kilonewton proof load, E600, but usually in a road and street application where it can be either D400 and E600. It will depend not on the traffic, because the traffic is, well, the vehicles are the same usually, but it will rather depends on the traffic pattern. So what is the speed of the traffic? But often it's going to be E600 if it's a road application. If it's a residential road, then D400 would be probably appropriate. And usually we don't want to install the trench drain where the cars are always perpendicular to the street, or where the cars are always moving. It can be done in a parking lot, but that would not be a good idea to do that on a road. So you want the system next to a curb. So
I think Dominic answered that well. I think in terms of the type of the loading on the grate, or the type of grate that's selected, obviously that's relevant to the particular application. And what we do, we can obviously advise customers on grate selection and loading as well. There are some, when you look at an application area, you've got to take into account all the different factors of that area to choose the grate, to select the particular grate. So it's not just on loading; it's on there are other factors as well, which Dominic mentioned.
Excellent. This is an interesting one. If your modular trench is installed in a very flat area, does the trench have to have a built-in slope that will facilitate flow?
That's a really interesting question. Well, we have the hydraulic program that we use to choose the right system. But to answer the question quickly, no, it does not need to have a gradient, even if it's a level system, a level surface. I mean, a gradient that is equal to 0, because you can make sure that the water will find its way out to the outlet, even if the system is installed without a slope. And if we compare a built-in slope system and a level system, the difference in the hydraulic performance is very small. Usually, if the system is not appropriate, you would not be looking at a built-in slope, but rather looking at a larger product. What can be done is a step-fall system, which is a better alternative to a built-in slope, in our opinion. So basically what you do is you choose a shallower system connected to units that have a deeper invert. And then you can create, this installation will create steps which create a gradient, or that is similar to a built-in slope. But this will be used mainly when you have long trench drain runs.
Excellent. Are there any examples or instances where linear modular trench drain systems are incorporated into green infrastructure for low impact development?
Jamie, can you probably have some example?
I think that might refer to using a trench drain system as a water attenuation system, as a storage system, and again these systems are integrated into water attenuation systems. So what we can do is we can provide high capacity trench drain systems, and typically larger units are used, and the trench drain run will be a larger trench drain unit, and that can be used to store water. And you fit a flow regulator on the end of at the catch basin end to regulate the flow of water away from the trench drain. So again, these systems can be integrated into the overall drainage system to help conserve or to help gather and then store and maybe recycle stormwater. So again, we can help with regard to the design. We can help with the design to design a system, integrate a system into water storage, water attenuation systems. So that's something that we can help with as well.
We did get a few people asking questions about per linear foot pricing, and I know given that Canada is a big country, there's other factors, but Dominic, maybe you want to give your answer in terms of how you might respond to that?
No, it's difficult. It's really difficult because again, it will depend on the location of the project, and also it will definitely depend on the system that we have choose. So we have a very large range of system, and different. Of course, the pricing is totally different depending on the system. So and also the quantity that is ordered, where the freight will be better. So what I suggest is what we do usually is. If there is any inquiries or a specific project, then we will be pleased to look at the project and go through the selection process and recommend the system, and then provide a budget pricing for this system. This can be done easily, but it's difficult to give a general range of price, unfortunately.
Questions, so we'll answer them speedy, and then we'll wrap up here. There's one, and I think the questions about weather are really important, so I wanted to get to this one. Why is the PP material frost resistant?
Because it does not absorb water, so that's why it's frost resistant. Also, the concrete surrounding the system, of course, we need to choose the proper concrete that needs to be frost resistant as well. But there's no issue with the polypropylene itself because it does not absorb water. So.
And there was a question: is this a product currently available in BC and Alberta?
Sorry, what was the question?
Is it currently available in BC and Alberta?
Yeah, sure it is. Yep.
Great. There are quite a few more questions. I'm going to close off in the next minute or so, but if you do want to get your questions answered, Dominic does see all of these, and we respond directly via email. So you can get your questions in here. Also, when you exit, there's an exit survey. Again, make sure you choose yes on the email question. I believe it's number 4, or you'll never hear from us again. And there's also an opportunity there to ask a technical question if you wish. There's also a question there which I believe asks you whether or not you would like to discuss your project with us. So obviously we're happy to discuss with you individually. Thanks everyone. Have a wonderful Friday. Thanks again to our speakers for a great presentation, and keep an eye out. We'll get the CPD certificate emails out there, and those will include links to the YouTube video and to the presentation if you'd like to share it with your colleagues. Thanks very much.
Thank you, everyone.
Thank you, everyone.
Thank you.